Hello everyone. In this video, I'm going to show you how to configure a CFD computation in Meteodyn WT. So open the WT product and open your site. Once the site has been configured, so the coordinates, the radius, the geographical data, as well as all the elements of the site, open the CFD computation panel, which is this one, and click on Create a Computation to create a new CFD. The new computation panel will open. So a CFD computation is launched for one direction and one stability. The question of the wind will be solved, and the wind will propagate in the mesh in the direction chosen. So the first step is to choose the direction. So it is possible to launch several directions and several stability. This will lead to several computation launched. So when defining the direction, they can be defined by direction. So for example, if I want to launch the direction 15, this will be launched. Or it can be launched by step. For example, for the synthesis, the windrows must be launched. The minimum step is 45, so I need to launch at least 8 computation to be able to launch a synthesis. It can be more, for example, a step of 30. So I'm just going to show you for one direction. Then you can choose the stability. It's the same. You can choose several stabilities. This will lead to several computation. So unstable, neutral, or stable. The default value is neutral. It is the one we advise if you don't know the atmospheric stability of your site. If you have input some mesoscale, microscale coupling data, the option will be available and you can just activate it. And other parameters are available, such as the buffer layers height for the forest model, the tree height roughness ratio, and the default roughness. Then the second step is to fill the domain parameter. These are the parameters for the mesh, the generation of the mesh. So the minimum horizontal resolution is the resolution of the mesh around the interest point. So 25 meters is the default value, and it will expand with a horizontal expansion coefficient defined here. The minimum vertical resolution is the size of the cell at the surface, and then it will also expand. The expansion coefficient can be defined in the user parameter here, vertical expansion coefficient. The Atlas option allows to define several micro CFD, so the domain will be divided and the computation can be divided if the domain is too big and there is not enough resources. Each micro CFD will be computed, and then there will be smoothing to match the CFD and get the whole domain. So other parameters for the domain parameter can be defined, such as the verticality parameter, the smoothing data for the Atlas option, the smoothing on the border of the domain, and for the LiDAR, the horizontal resolution and the horizontal expansion coefficient. Then the third step is the configuration of the solver parameters, so the number of cores per direction, and the maximum iteration number. So when a CFD is launched, it will stop when 100% convergence has been reached. This option will force all the iteration to be launched, even if 100% has been reached. So activating this option might lead to convergence of more than 100%. A keep volumic mesh to allow additional iteration allows to store the result at the end of the computation. And if you relaunch the computation, it will use the last iteration results. And so this allows to add more iteration. And then additional options for the conversions, so the conversion monitoring and the auto conversions can be activated to have the best conversions. Then you can parameterize the priority of the job if there is several jobs that are launched, and also more advanced parameter to adjust the solver. If you go on each parameter with the mouse, you will get the definition of each parameter. Then, if you are launching your simulation in local mode, you can first estimate the memory of your computation to check if you have enough resources. So you get the memory. So after checking that everything has been configured, you can launch your computation. So either on HPC or in local mode, and the computation will start. You can monitor the conversions and check the evolution of the computation. Okay, so the computation is finished. It is possible when clicking on the computation to display the properties of the computation. If the option of keeping the volumic mesh, it is possible to add iteration, or otherwise to launch again the computation. It's possible to delete it and to also monitor the conversions. So select the elements and then all the parameters that are computed can be monitored. Finally, it is possible to see the results. So for each element, visualize the results. So for each point, the value of the speed and the turbulence intensity, the deviation and the inflow angle are displayed. And it is also possible to visualize the results on the map. So this is the result of the mapping, but it is possible to see the results on the entire domain. Just simply select the height and the results will be displayed for the entire domain here. So in the direction that has been chosen, which is direction 0. It is possible to visualize the mesh just by clicking here. So we see that for each interest point, the mesh is very refined. For the mapping, it is also refined. And outside of the interest zone, it is less refined, but the expansion coefficient. So the different result can be displayed, the deviation, the turbulence intensity, and the legend can be displayed by clicking on the I button. So the CFD computation has been launched. You know now how to configure it and see the results. More information can be seen on the user manual, the Meteodyn Universe Macroscale user manual. So check out for more details. Thank you for your attention.